Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Fossil fuels. What is crude oil, or also called petroleum? How do we turn it into something useful? So you should know that your crude oil is a mixture of hydrocarbons of various chain lengths. And a hydrocarbon is literally just a molecule that only has hydrogen and carbon in it. And you turn it into something useful using fractional distillation. And you produce these fractions. These are groups of hydrocarbons that have similar chain lengths. And the reason I need to group them into these similar chain lengths is because a similar chain length gives me similar properties. So how do the fractions differ? Well, in your fractionating column that you use to split this crude oil up into its different fractions and chain lengths, you basically just have a temperature gradient. You have your bottom of your column that is hot and it gets cooler and cooler and cooler, and fractions are siphoned off at various different temperature gradients. So your long chains get taken off at the bottom and your short chains get taken off at the top. And the reason that happens is because of their boiling points. So your short chains have a low boiling point, which means that they will not condense and form a liquid until they have made their way up that fractionating column to a low enough temperature. This affects their volatility as well. So those short chains are quite volatile. They're more likely to be gases, for example, at room temperature, whereas your longer chains are more likely to be liquid, so they're not very volatile. Viscosity, your longer chains are more viscous than your shorter chains. And that one you need to be careful to talk about your intermolecular forces. Those longer chains have higher large intermolecular forces of attraction between those long molecules, which gives it its viscosity. Don't burn easily ignited. So my short chains are easily ignited. They're more likely to be gases. So how do we meet demand for different fractions? Well, the problem really is that our long chain hydrocarbons are actually in quite low demand and our short chain hydrocarbons are in high demand. So to meet the demand, we use this process called cracking, which is where we take those longer chain ones and basically break them up into shorter chain ones, because we can use those shorter chain ones in things like fuel, and that's because of some of their properties, like they're easily ignited. So what is a combustion reaction? So it's any reaction with oxygen, but we're going to be talking specifically about hydrocarbon combustion. So these two types of combustion, we can either have it as complete combustion, where you have plenty of oxygen gas and then you get these products of water and carbon dioxide, or it can be incomplete combustion, where you don't have enough oxygen and the products you end up making there are carbon in the form of soot, carbon monoxide and water. So in reality, do we ever get 100% complete combustion, or do we ever get 100% incomplete combustion? And no, it is a bit of a mixture. So you get a list of all of those products really in these combustions. So now time to try and balance an equation. So this is a combustion reaction. How can I tell? Because it is that reaction. I've got a hydrocarbon made of just carbon and hydrogen, and that is reacting with oxygen, O2. So that's how I can tell. And then on my right-hand side, I can already see some carbon monoxide, and some water. So this is an incomplete combustion reaction. So let me try and balance this. I put that 2 in front of my CO there, my carbon monoxide, because first job is to balance the carbons. We're going to leave the oxygens, there's too many of them flying around, we leave those till last. And on my left hand side, I've got 5 carbon. On my right hand side, I had 3 coming from that carbon of the kind of soot carbon. And then I had just 1 coming from this carbon monoxide. So if I put a 2 in front of that carbon monoxide, Now I have 5 carbons on both sides. Now let's have a look at my hydrogen. On my left-hand side, I have 12, and on my right-hand side, I have 2. So if I put a big 6 in front of that water, 6 times 2 is 12. So now I have got 12 on both sides of hydrogen, and always leaving my oxygen until last. So now let me count my oxygen and see where I'm at. On my right-hand side, I've got 6 from the H2O and 2 from the carbon monoxide, that's 8. And on my left-hand side, I only have O2, so I only have 2. But if I multiply that O2 by 4, that gives me 8. 4 times 2 is 8. Okay, pollutants. So what are the main pollutants that come from the combustion of fossil fuels and how are they produced? So we have our carbon and our carbon monoxide. Those are both from the incomplete combustion that we just did on the page before, and that's when you have not enough oxygen in this combustion reaction. If you're part of the IGCSE Edexcel, you don't need to worry too much about the particulates of carbon, so about that soot, just that plain C there, but do worry about the carbon monoxide. Everybody else, you need to worry about both of them, and then everyone needs to worry about the following as well. Your nitrogen, various nitrogen oxides, that X there just means it can bond in different ways with different amounts of oxygens. And so you get nitrogen from the atmosphere, and the temperature is large enough for it to react with the oxygen, forming some kind of nitrogen oxide. And you get sulfur, which is an impurity in some of your fossil fuels, also reacting with oxygen from the atmosphere and forming a sulfur dioxide. And both of those can dissolve in water in the clouds, form acid, and that's how you can get acid rain.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets and completely for free, so why not?
Okay, tips and tricks. First one, do the mind the gaps properly. Make sure you know the names and uses of crude oil, petroleum fractions. And try making your own mnemonic using a mnemonic generator website if that helps you to know all of the different layers and all of their various uses as well. When balancing combustion equations, leave the oxygen till last. There's too many oxygens flying around. It makes the process a little bit simpler. And remember to just keep going. Sometimes you do have to add multiple numbers in front of your equations till they balance. When you're explaining how a pollutant is made, make sure you explain where the reactants come from. So for example, you're talking about sulfur dioxide, you should mention the sulfur is from impurities that are found in the fossil fuels before they undergo combustion.